All right, welcome to the lecture for IT 450, IT 462. This is going to be an online lecture, and we're going to go ahead and get started. Okay, so what we're going to go through is some basic refreshers on programming concepts. We're going to do a brief discussion on Arduino, and then some electronic fundamentals, and particularly we're going to talk about the Extra Credit Lab 2 and what you need to do in order to make that successfully work. All right? Okay, rule 1, you need to comment your code. Your grades depend on it. What I've found is I've ran this class is that if you can't tell me why you're using that code, you don't know why you're using it, and you can't troubleshoot your code. And if you just stab it in the dark, you really don't know, you really haven't learned the material. So comment your code because your grade does depend on it. Okay, programming variables. This should all be refresher. We have integers, we have booleans, we have characters, we have strings, which are text, right? A chunk of text. We have float, which is decimals, long integers, and then of course we have variables. So within the Arduino context, we have different pin positions. There are analog pins, there are digital pins. You need to make sure you're using the correct pin type based off your sensor or actuator, okay? LEDs typically are gonna be on the one side of the board. You'll actually should see in some of your labs the orientation on that. Make sure you are using digital pins appropriately. Those would be for LEDs typically. Analog pins are where you're going to use your sensor. So you're going to do an analog to digital conversion. That's typically what's happening there. When we declare a constant, so we may say analog pin 1 is the light sensor and analog pin 2, so we might call it light for the variable name, and I set it. And I use a, quote, user-friendly name instead of having to remember that sensor position 1 is the light sensor, okay? Whereas sensor position 3 may be the temperature sensor, okay? So these are reasons why we use a constant variable. We have operators. So operators, we set values. So we say x is equal to something. It can be y plus 1. We can increment it with x plus plus. We can decrement it with x minus minus. These are actually changing the value of the variable when it's not a constant, okay? Because obviously, typically with variables, we want to update that as we do evaluations of data and sensors, etc. Comparison operators, most of these everybody does well with. The one that I tend to see people run into trouble with is if I do an if statement, let's say if x is equal to y, if you do not use equal equal, what you're doing is saying I'm going to set x to the value of y, but if it's within an if statement, it actually gets kludgy, and it becomes problematic because you're actually doing the opposite of evaluating it, you're setting it. So hence the first one, x is equal to y, is where I see a lot of issues. You're going to want to make sure you do that correctly. The rest, pretty straightforward, and they're usually not messed up as far as trying to set. So you can set up function calls and statements. So when you set up a function name, you pass it variables. So for instance, the digital write, so let's say we have an LED on position 5. So I might call that LED, so I would do digital write LED, let's say LED 1, because it's the first LED, even though it's in position 5, just because I set it that way. There's no meaning behind that, I just set it that way. And then high turns on the voltage, low turns it off. It's pretty straightforward. Delay, one of the biggest mistakes I see with people with delays is that when you tell the board to delay, it does nothing but pause. So it doesn't monitor sensor inputs, it doesn't change output values, it literally pauses everything. So when you use this, you need to use it judiciously, all right? Arduinos are limited. These are not full computers. You should know that. These also mimic what we see in ECUs, obviously on a very simplistic basis. Same thing with programmable logic controllers. So these are all things that you need to keep in mind. So don't write giant swaths of code that are unnecessary. Only write what you need, okay? Here we have some examples of setting up variables. You have to set up your variables. If you want to be able to output to screen, I recommend creating a function to do output. We'll see an example of that here coming up on an additional slide. You also have to do setup. So if you have a pin, whether that's an input or output, so let's say you have a digital input, you would do pin mode, then the variable name for that pin position, and then you would do input. In this example, we have output. So this is basically setting up an output pin for an LED. We also have to say turn on serial communications so that we can pass data over to USB. That has to be in the setup. Otherwise, when you try to do the data passage through serial monitor, you will get nothing. All right, so this has to be there. Loop is like the main, and then of course we have a chunk of code doing things here. All right, and then it just runs whatever's within that loop, and then it just does it again and does it again in perpetuity. Okay, serial monitor is your friend. So for instance, when we're using light sensors and temperature sensors, you don't know exactly the values based off the light level or the actual temperature in the room, what that voltage is coming out. So you actually have to play with it a little bit. Best way to do that is to set up serial monitor and output data to screen. That's why you're hearing me say this is your friend. As we go through the different labs and stuff, if you do not understand how to do this, you need to come in and work with us. We'll work with you and help you get through this. The reality is you won't get through all the labs and you won't be able to finish the final if you don't understand how to use serial monitor to test your code and troubleshoot it, because you will have to do that before you turn it in. If you turn in code that does not work, you will not get credit for it. Okay, so for extra credit 2, what I'm going to ask you to do is create a Morse code example. Instead of SOS, you have to blink your first name in Morse code. What I would recommend is compartmentalize your code. Don't write long main loops. If you do, and I'll show you an example here in a second, you're going to create a giant dumpster fire that you cannot troubleshoot. And then you're going to get frustrated and not know what to do. And then you're going to come to me and say, this stuff doesn't work. And in essence, your argument is invalid because you set yourself up for failure. So what does that look like? What that looks like is this, is on the right, the code between serial output D and serial output A is, I think, roughly 12 lines of code. It does the exact same thing as what I have on the left that says Morse D. I have created a function, Morse D, that actually calls other functions. So when I say compartmentalize, I mean create code, small chunks of code that are easy to troubleshoot and call them, obviously sometimes repetitively, instead of rewriting that code from scratch. So on the right is the long main that I'm telling you don't do this. People tend to do this and it actually becomes immensely difficult to troubleshoot. If you do it like I have an example on the left, it becomes way easier. So for me, I can tell you right now, if I look on the left and go, oh, Morse D, I've written a function that is supposed to flash the letter D according to Morse code. Super, super easy to troubleshoot. If I look on the right, I'm like, wait a minute, there's 12 lines. What am I doing here? Okay, what is that actually? Which is the dots? Which is the dashes? Now I'm going to go back and look. Wait, oh, and it takes way longer. Structure and organization is your friend. Okay, so here is an example of a version to do the Extra Credit Lab 2. So we have to declare the LED is pin 13. That is the onboard LED that you get to blink. We've declared it as a constant because we don't want that to change. We have a void setup. Again, we've declared pin mode. We have our serial begin, so we can actually use the serial monitor. Then we have serial output. Note here that I have it set up to take an input variable of string, and I call that output value. And then in the serial print, I just print that value to screen. And then I drop down a line with the /n. In the void dot, this is actually the appropriate flash sequence for a Morse code dot. The timing that you use can be slightly different, but you have a high and a low. So I've set that up with delays so that it blinks in the format that I want for the dot. We then have a dash function. This is to, I'll say, compartmentalize a dash function, all right, which is a longer run than a dot. So dot is literally the circle dot. The minus symbol is the dash. So if you go out on Wikipedia, if you look up the Morse code translation, it'll say A is like a dot and a dash or something. So now that we've kind of gone through those, please note I have commenting on every line of this code. All right, I expect the same from you. And then here we actually have, so I set up, so my name, obviously Dave, has a D and an A. I'm not giving you everything. So I basically declared a void function. So void function name Morris D. And then I put in the appropriate dashes and dots in order to signify that letter in Morse code. I do the same thing with Morris A. All right, that's by looking up on Wikipedia on how to translate that. And then down in my name, I have serial output. Remember, whatever I put in there in quotes will then be passed to screen. If I turn on the serial monitor, I also then call my function Morris D, which is named adeptly for me to know that when I call that function, I'm actually doing Morse code D. And then I have serial output A, and then Morse code A is called. And then it loops and starts over again. You need to create the appropriate letters and flash sequence for each letter within your name. You need to use the conversion from the letter to the dots and dashes. That is what you need to do to complete the Extra Credit Lab. This is a good exercise on getting used to serial monitor, compartmentalizing code, and actually writing good, clean, structured code. If you have questions, get with me or coming in on the weekend open lab, or try to get some time with Mark in the lab before class.